And, oh, I have actually, I can steal it from another slide. Here we go. Here we go. So copy that. So I've had this theme so far of chocolate bars. I pre-made a chocolate bar so I didn't have to color it in every single time. There's a whole chocolate bar. Okay, I'm actually going to make multiple chocolate bars. Okay, I have this chocolate bar. I have 2 chocolate bars. And unfortunately, I ate half of one.
He was hungry.
Yeah. So does it make sense that if you cut this chocolate bar into 2 pieces, that would be a half? And I ate half of it. Gobble, gobble, gobble. Come on. Gobble, gobble. I'm a little bit of a messy eater. Sometimes I leave some crumbs. Okay. I ate half of that chocolate bar. The other one, I only had a third left. So if I broke this into 3 pieces, maybe I break it this way, I ate 2/3. I only have a third left, so I have some crumbs. And if I glue these together, the question is, how much chocolate bar do I have left? And right now that looks complicated, but the idea is going to be easier if our chocolate bar was shaped differently to begin with. Okay? So notice I cut this one in half up and down, and I cut this one in half left and right. I'm going to erase my eating, and I'm going to cut this one in half up and down, and this one into thirds left and right, just like I did before. But now I'm going to go back to my first one and cut this one into thirds left and right, and cut this one into half up and down. Okay? How many pieces does this chocolate bar have? If I cut it that way. 6. Okay? And if I had half of the chocolate bar, how many pieces would that be?
3.
3 pieces. Half of the chocolate bar is 3 pieces. How much is a third of the chocolate bar? How many pieces is a third of the chocolate bar? Right? If you break off the 3s and you take only one of those 3 sections, how many pieces is that?
2.
2 pieces.
So that'd be 3 over 2.
Okay? Half of the chocolate bar is 3 pieces. A third of the chocolate bar is 2 pieces. If I had a third of the chocolate bar and a half of the chocolate bar and I added that together, how many pieces would I have? Now the math gets really easy. If I have 3 pieces and I add 2 pieces, how many pieces do I have?
5.
5. Right? That math seems really easy. Okay? This is what we're doing when we're doing fraction adding. What we're trying to do is we're trying to figure out, when I just had the half piece and the third piece, they looked really awkward to add together because they were different sizes. If my pieces are all the same size, then I can add them up and life gets a lot easier. So what I did with my half and my third by doing it this way, I found out that I could get things the same size if I made it in 6 pieces. In mathematics, we say, find the lowest common denominator, which in looking at the 2 and the 3, it's like if I split my chocolate bar in half this way and 3 this way, it would make 6 pieces. So in mathematics, what people do is they say, well, if I have a half and I have plus a third, I want to get the pieces the same size. And a number in my times table that's both with 2's and with 3's, if I skip count by 2's, 2, 4, 6. If I skip count by 3's, 3, 6. The first one that I skip count and hit the same number is 6. My times table comes into play here because now I'm looking at 2 times something and 3 times something have to be the same answer. And if you can see that 6, you would tell yourself, I know I have to multiply the 2 by 3. But then I also have to multiply the 1 by 3 because you just told me earlier that half the chocolate bar is now 3 pieces if my sizes are 6 of them. And my 3, I'd have to multiply that by 2, then I'd have to multiply the top by 2. And we said that a third of the chocolate bar was 2 pieces. And so what happens is we take our original fraction, which was 1/2 plus 1/3, and we rewrite it so the pieces are the same size. Because right now, when I say 1/2, I have 1 piece where the whole chocolate bar was cut into 2. And when I have 1/3, I have 1 piece where the whole chocolate bar was cut into 3. It's hard to add those together because the sizes are different. But if I make the sizes the same, now I have 3 pieces of size 6 plus another 2 pieces of size 6. I'm going to have 5 pieces, which you said, and the pieces are of size 6. So the answer to this will be 5/6. Now let's look at the steps. So we talked about what we needed to do with chocolate bars. It all makes sense. In the step it says find the lowest common denominator. The denominator are the bottom of the fraction. And that's where you're looking in your times table or your step counting and saying, what in my times table is the same for 2s and 3s? We often want to find the lowest one because it makes our math easier. But it doesn't have to be. It'll still work if it's not the lowest one. Because can you see that you could break this chocolate bar even in more pieces and still eat half and still eat a third? Your math will still work, even though the pieces are smaller. But when the pieces are smaller, sometimes you have bigger numbers to work with. If we get the lowest one, it usually makes our math a little bit easier. Okay? So we write each fraction with the same lowest common denominator. That's what we did right here when we had 3/6 and 2/6. Now, I'm going to add those lines there. You notice how I multiplied the top by 3 and the bottom by 3. And over here I multiplied the top by 2 and the bottom by 2. That changed my 1/2 to 3/6. If I eat half the chocolate bar, does it make sense that I eat 3 out of the pieces that are size 6? They're the same thing. When we multiply the same number on the top and the same number on the bottom, just do some mental math. I'm going to check your dividing. What is 3 divided by 3? 1. What is 2 divided by 2? 1. What happens when you multiply by 1? Does it change it? No, it keeps it the same. But the weird thing in fractions is we kept it the same, but made it look different. Okay? I need a haircut. I'm going to have to get a haircut in the next week. I'm going to look different, but I'm going to be the same person that I was before, just with a different haircut. That's multiplying by the 1 changes the fraction from 1/2 to counting it in a different way, 3/6, but it still means the same thing. And once we got our pieces the same size, so adding and subtracting only works well if you're adding and subtracting the same sizes of things. Right? If I have a $10 bill and a $5 bill, I don't have $2 because I have one here and one here. I can't just add that, right? They're different sizes, so it adds up to something different. Once they're the same size with these 6s, then it's just like the bottom number tells you how big the pieces are. The top number tells you how many you have of that piece. That's what a fraction is talking about. You have the whole is divided into 6 pieces, and you have 3 of them. And you have another 2 pieces, and if the sizes are the same, then it's really easy to see that you have 5 pieces in the end of size 6. That is the concept of adding and subtracting fractions and why we do it. Okay? All right. I want you guys to do some predictions. Your friend is doing this and does it wrong. What do you think answers people? What do you think the number one mistake people who add fractions wrong, what do you think they're going to write?
Like 5 over, not 2 over 5.
2 over 5. That's a great wrong answer. What did your friend do?
She like asked me like, how do we like do it?
You're used to just adding numbers, right? So her friend added the 1 plus 1 and got 2, and added the 2 plus 3 and got 5. And if you don't know what a fraction is, you could be tempted just to make up like, I know how to add. So 2 out of 5 is a very good wrong answer that people get. But they're not understanding what a fraction is. So the key thing is understanding that a fraction says you started off with something whole and you've only got part of it. It divides that into different parts. So let's do, I'm going to steal my chocolate bars again. Yeah. I like this button. I can clone things and then I can get, this would be so nice. If you could actually do that with real objects, like get a real chocolate bar, just hit the clone button, and then you could just drag it and get another one. Whenever I want a chocolate bar.
It'd be so worth paying for one.
I'd be so fat. I would be so much chocolate in me. Maybe this is a good thing you can't do this. Okay. Three-fifths would be like my chocolate bar split into 5 pieces. This is actually a good try and spatial activity. I did not bad. Can I draw lines in my brain and make it 5 pieces? They should be perfectly equal. You might have to use your imagination a little bit there. I think I did not bad. Are you okay that those 5 pieces are about the same? So 3/5 would be 3 of those pieces. And if I talked about thirds, well, I did my thirds this way last time, I'll do that again.
I was gonna say.
Okay, there we go, there we go.
You could go the other way.
I could, but then I want to put them together again.
Yeah.
So if I do one direction and the other direction, then that puts them together.
That's good.
Okay? So, I am going to take the 5s and draw them down like this. And I'm going to take the thirds and draw them across like this. And imagine this as the chocolate bar to begin with. How many pieces did the chocolate bar have to begin with?
5.
5? I got more. 1, 2. How many pieces in total?
15.
15. Okay. If you ate 3/5 of this, how many pieces would that be? More than? Well, now that it's broken up. Okay. So remember, the fifths were up and down, right? When you break off a fifth, you get 3 pieces all at once. Do some of you? My daughter eats chocolate this way. Breaks off the whole roll. And I'm like, oh. And I'm a saver. I don't share well with people like that because they eat like all of it and I'm still on my first piece enjoying it. And then I look back and the whole thing's gone and like, they're gobblers. Eat it up that fast. So how many pieces would 3/5 be? This is 1/5. This is 2/5, 3/5, 4/5, 5/5. They ate 3/5. How many pieces did they eat?
9.
9 pieces. Okay? And when I think about 2/3, my thirds were this way, right? This is a third, this is a third, this is a third. When we talk about a fraction as a third, we took the whole thing and broke it into 3 equal pieces. How many pieces would it be if you ate 2/3?
Six.
Close. Count them across, right? And this is 1/3. This would be 2/3.
10.
So it's going to be 10 pieces.
Some of you are recognizing that you may need to make a little blemish or a spot to say, and shade them in. Maybe that helps.
Yeah. So if I had 3/5 plus 2/3, and 3/5 was 9 pieces, and 2/3 was 10 pieces, how many pieces do you have left in total? This is not hard. This is the easy part. You have 9 pieces from one, 10 pieces from the other. How many pieces in total? 19 pieces. Okay? Now, how does this show up in the math? You can always draw the chocolate bars. Okay? You have 19 pieces in total. How big are the pieces? How much was the chocolate bar split into? 15 pieces. So the answer to this is going to be 19 over 15, which what we did yesterday, we could also write this as a mixed fraction. I'm only going to give you one number in the mixed fraction. The 15 stays on the bottom. What number would be out in front?
1 whole.
1 whole. And how many left?
4.
4. Makes sense because 15 would make that whole chocolate bar. And you had 19 pieces, so you'd have 4 pieces left. Okay. All right, good luck in football. So, from here, how do we do this if we didn't draw out the chocolate bars and count pieces? Because as much fun as it is to draw out chocolate bars, eventually, you're like normal students. You like to get your homework done quick. You're doing stuff in class, you like to get it done as efficiently as possible. What do the mathematicians do? They say, if I have to add 3/5 plus 2/3, I look at the numbers on the bottom and say my pieces are different sizes. This doesn't let me add. What in my times table of 5 and my times table of 3 is the same? It's 15. And a shortcut that doesn't always give you the lowest one is you can always do this times this. That doesn't always give you the lowest one. I can make an example where it doesn't give you the lowest one, but it still will give you a good answer. So if it's 15, that means this one I need to multiply by 3 down here, which means I need to multiply by 3 up there. Multiply by 1 changes what it looks like, but doesn't change what it's equal to. And this one I multiply by 5 down here, and 5 up here. Again, I multiply by 1. Doesn't change what it's equal to, just changes what it looks like. All right? So, 3 times 3. There's our times table. Comes up again. 3 times 5, 15. Plus 2 times 5, 10. 3 times 5, 15. Again, what does a fraction mean? This is how much the whole thing was cut up into. In other words, our chocolate bar had 15 pieces. This is how many you have of that. You have 9 pieces out of 15. And here you have 10 pieces out of 15. And since the pieces are the same size, now it makes sense to add them. I have 19 pieces in total, because 9 plus 10 is 19. The pieces, if you add them, the pieces don't change size. Okay, just like what you said your friend would do. Your friend might put 30 on the bottom. You might be tempted to write 30 on the bottom. What you just did then is you added them together and all of a sudden miraculously changed size? That doesn't make sense. So the bottom number has to stay the same because it's how big the pieces were. And we get 19 over 15, which, from what we learned yesterday, you could write this also as 1 4/15. Both of those are nice numbers. It tells me I've got a whole chocolate bar left. Life is going to be good for a while. And an extra 4 pieces. Okay, now, we did 2 together. I want to do this one together still.
Yeah.
I have 1/8 plus 1/6.
It's a heavy one.
I actually have 2/8 plus 1/6. And we can go about this. I'm going to start it off in the same way. And then I'm going to show you some interesting things that could come up with this question. So is this my chocolate bar? Oh yeah, this is the one that repeats itself. This one? Got it. All right. So 2/8. Again, I'm going to split one way and 1 the other way. When I'm doing 8, that's my technique
Nice.
for doing 8.
Split it in half.
Split it in half and
Split
then
it in half.
there's 8 pieces that way. And if I do 6, split it in half, and then I have to do 3 up here. Ooh boy. A little tricky. Especially because okay. You guys have a very good imagination. You can imagine that those lines are perfectly straight and equally spaced. How's your imagination? Good? So what I'm going to do before I talk about pieces here is I'm going to color 2 of the 8 this way. And I'm going to color 1 of the 6 this way. I'm going to do the bottom one here. And I'm going to take my 8 lines from here. Oh. I'm going to pause.
That's better late than never. A fib mostly, just a fib.
Good to go. Okay. So I drew my 2/8 and I drew my 1/6. And now if I go to my 8ths one and draw 6 across, so I have to take 1, 2, 3, 4, 5 lines. See how there's 5 lines to draw 6 across? From there. Whoa, that was weird. 2 out of 8 is how many pieces? Now that I've got them, that's why I did it in blue. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do you agree with that? 12 pieces. And here, if I go and break this into 8, this 1/6 is how many pieces? 8 pieces. When I had 8 this way and 6 this way, 8 times table. When I have 8 one way, 6 another way, how many pieces are in total? Will be 8 times 6. 40.
Say it out loud.
Yeah, you missed. We had a times table competition in the beginning. 48.
Yeah, and you could have won it. But now, you'll never know. You'll never know what you don't achieve.
And there's 48 pieces and you have 12 pieces plus 8 pieces. Does it make sense that you have 20 out of 48 in the end? Now, 20 out of 48, there's a number you can divide both those by. Especially if they're both even numbers. If 2 numbers are even, you can divide both of them by 2. So, if I divided the top by 2 and the bottom by 2, it changes what it looks like, but doesn't change what it equals to. So I can divide them both by 2. I could get 10 over 24. They're both even numbers again. I could divide them in half. Again, what would I get if I divided the top in half?
These expressions on point. Like, how do you feel about what's happening right now? I like it.
This reduces it down to be 5 over 12. Now, mathematicians will say this is the best answer, and they would call that in simplest or in lowest terms. They want things in lowest terms. 20 out of 48 is the right answer, but the lowest term answer is 5 out of 12. So, if we take away the chocolate bars, and we go to do this, what are some of the things that we could do that might make this easier? And one of the things that I think makes...
Did we make a mistake? Oh no.
Did we? I think we're good.
My brain's probably just playing tricks.
Okay. So, I'm going to show you now the numbers way. And one of the things that's, I think, fun, because I like math, I know. So you'll hear me say fun, because I'm like, ooh, this is going to be fun. One of the things I find fun is when there are, like, I could do it this way, that makes sense to me. I could do it this way, that makes sense to me. And those two ways are a little bit different, but they're both going to be right if they make sense, and of course you don't make any little mistakes along the way. So, what I'm going to do now is I'm going to not do the chocolate bars where I count the pieces. I'm going to go to the fractions. In order to add them, the bottom numbers have to be the same size. And we go to our times table. We happen to use 8 times 6 and 48 pieces. But I want you to think of your times table because there's a number smaller in your times table for 8, skip counting by 8s, and skip counting by 6s. What is a smaller number than 48? That's the same. This one's going to get multiplied by something, and this one's going to get multiplied by something. Something times 8 equals something times 6, and it's smaller than 48.
24.
24. Beautiful. Can you see that you can do 6 times 4? So then I'd also have to multiply the top by 4, because I multiplied by 1. Changes what it looks like, doesn't change what it's equal to. Bottom here,
8 times 3.
8 times 3, so I'd also have to multiply the top by 3. And then I would get 3 times 2 is 6 over 24, plus 4 times 1, 4 over 24. And this is like the chocolate bar was only split into 24 pieces. And you have 6 of those pieces plus 4 of those pieces, and you get 10 pieces. Notice that both those numbers are even, which means you can divide them both by 2. And if I divide them both by 2, on the top I would get a 5, on the bottom I would get a 12. Same answer we got as the other one, different way. I'm not done yet. I want to have fun again. Another person does this same question. Started off with 2 out of 8 plus 1 out of 6. And they said, hey, wait a minute. 2 and 8 are both even numbers. I could reduce that fraction right at the beginning. And I will tell you that if you reduce things early,
I love that.
it makes your math easier. So I don't know if I should tell you to do that. Maybe you should do harder math. No. Part of the fun is finding an easier way to do things. So I can divide this by 2. Do you see that you would get 1? Divide this by 2. Look at our picture. Does 2 out of 8, if I circle this, maybe. And then I circle the same size here, maybe. And my pen will eventually start working, maybe. I don't know. There it is. Okay. Can you see that the blue part is now 1 out of the 4 green circles? 2 out of 8 is the same as 1 out of 4. And now I have this. Oh, there's a delay today.
And yeah, just disappearing on you.
It's like struggling. My
But at least
computer
it's not on.
is struggling.
It's
Man.
on.
Whoa!
What?
It listened to me. It got mad. Oh my goodness. Oh, I shouldn't have. You have to be okay. Smartboards apparently have feelings. It like totally destroyed it.
No.
I don't see it there anymore. Where did it go? Where did all my chocolate bars go? There we go.
Reduce.
We were where we noticed the 2 and the 8 we could reduce to 1/4. And we had this. Now, 24 does work. 4 times 6 is 24. It does work as a way to get the pieces the same size, but there is a smaller number. Skip count by 6s, skip count by 4s. 12 is in both of those timetables. So I can multiply the 6 by 2 and 2, and this by 3 and 3. And now I get 3 out of 12 plus 2 out of 12.
5 out of 12?
And that is 5 out of 12, which is the same answer we got every single other time, but my final answer I don't have to reduce. So sometimes if we reduce early, it means our final answer we don't have to reduce. And sometimes if we don't, it's not wrong, but it means you might have work to do at the end. It's nice to see that you have those options. So if you did it a little bit differently than a friend, it's not necessarily that you did it wrong, but just different ways of seeing the same thing.
There is a bonus to doing it first or early. Lower numbers, easier to reduce.
All right, so the next one, that's there. Now I want you to try the next one on your own.
What if you do?
If you did it already, you can do the one right after that. If you've done the next 2 already, perfect. I like that you've been working ahead. So try, there's 2 and 3. I want you to try those ones on your own. I will put up the answers in a bit, and you can call over for Mr. Shirk or myself for help. For the first one, and the answer is 29 out of 35. So we had to multiply the 3/7 by 5 and 5 to get 35. We had to multiply the 2/5 by 7 and 7 to get the 35. So again, if I was starting this right from the beginning, and I was doing this, I need my pieces to be the same size, and the 7s and 5ths are not the same size. I go to my times table, I think about skip counting. This one needs to be multiplied by 7, this one by 5.
There's just a lot of, I know it's a lot of whatever, but just want to do so now, just make it.
This will be 35 on the bottom and 15 on top. This will be 14 on the top and 35 on the bottom. And since they're the same size,
Because that's
now I can count how many pieces in total I have. 29 out of 35.
Did you do that one?
How did we do? One more to try on your own, and the thing that I'm going to do different on this one. The thing that I'm going to do different on this one is I'm going to write the answer down over here. And you have to show us that you got the work right to get there. So the answer to this one happens to be, ooh, I'm nervous, 13 on 50. You need to show me the work that you got that. So you just can't write down the answer. That's no work. You have to show that you got that. As an answer. Lucky number 13.
Is this how you